Hi everyone, welcome to your geometry play posit for the week. It's a little bit different since we had a holiday yesterday. You guys are going to be completing this prior to our class on Thursday. So make sure you go ahead and grab your notes, have your OMHS play posit graded assignment open, and let's get started. We're going to finish our notes from 10-8. Some of us did not get to finish going through the laws of logic. So we're going to finish that, and then we're going to talk more about conditional statements today. I wanted to bring something to your guys' attention. Maybe you saw it on your schedule last week, but we are going to start having geometry sessions with Ms. Jadala. They are extra sessions for you guys. Just another opportunity for you to get help. So we have office hours with Ms. Winslow, with myself, on Tuesdays at 2. And then you also now have this extra session you can go to on Fridays at 11. So if you can't make it to either of those, don't worry, they're going to always be recorded and you can always access them. The one on Friday is going to be topic specific, and you'll see that topic in your Class Connect schedule. So you can just look on that Friday and see what Ms. Jadala will be covering and decide if you want to go or not, or review the recording. This Friday, she's going to be doing a Unit 2 review. Attention! You guys, so we have two exciting things coming up. This Thursday at 1 o'clock, we have a visiting doctor. Dr. West is coming, and he's going to be hosting a virtual session for us. He promotes underrepresented minorities and women in STEM. So it's going to be an exciting session. You can find out more information in your science newsletter, but that is going to be this Thursday at 1 o'clock, and the session will appear as a live Zoom session on your plan. And then one of my favorites is our pet parade. That is going to be this Friday. Now, if you're in 7th grade, it's at 11 o'clock, and if you're in 8th grade, it is at 1 o'clock. It's super fun. And again, that Zoom session is going to be on your plan. All right, let's do this flashback. This is a way back flashback. This is an Algebra 1 topic, and I wanted to see if we could go over this and remember how to do this. So remember, you can always pause the play posit if you want to try something on your own in your own notes, and then you can press play to grab the answer. So whenever you see a number in front of a parentheses, it means to multiply and distribute. So we're going to distribute this -6. So -6 times 3 is -18. -6 times -3a is a positive 18a. Now we're going to do the same thing with this -8. We're going to multiply it by everything on the inside here. -8 times 6a, let's see, is that 48? Yeah, 48. Double check. 48a. And then -8 times 5, that's going to be a -40 equals 32. So that is the distributive property there. Now the goal is to solve for a. So we want to get all the a's together. So let's look on the left-hand side. We're going to go ahead and combine like terms. So anything that is similar. So remember, like terms they have the same variable. So these are like terms. And then these numbers are like terms because they're just numbers. So let's go ahead. I can rewrite it if you want. And you can also use your calculator to help you with this, you guys. The numbers are getting bigger. So first we're going to do -18 minus 40. And I am just going to grab my calculator to check. So it's two negatives, right? So it's going to be a -58. And then we're going to have 18 minus 48. So that's going to be a -30a. All right, let's move the 58 over to the right-hand side. We're going to do the inverse operation. The opposite of subtraction is addition. To move it over, these will cancel out because a -58 plus a +58 is 0. We'll bring down the -30. Add these together. 90. Now this is negative 30 times a, so the inverse of multiplication is division. So the opposite of multiplication is division. So that's how we can get rid of this negative 30. So a is, now we can simplify this, right? Is it just 3? Yeah, negative 3. Now, I also teach Algebra 1, and I always tell my algebra kids that you should check your work because you can. You have a calculator, you might as well check your work just to make sure you got the right answer. It only takes a few minutes, if that. So to check your work, all you do is plug in the value you got for the variable, in this case a, and make sure that it works. Make sure that the left-hand side does equal the right-hand side. So again, you can plug this into your calculator. I'm going to do this pretty quickly. You guys are in geometry. Hopefully this is coming back to you now. PEMDAS, parentheses first, right? This is negative 18. Now this will be a plus because a negative times a negative. So the beauty of doing this is potentially catching like a silly computational error. 7C104. And it always allows us to go back and check our work. And sometimes it's so simple and you're like, oh, I forgot a negative sign or whatever it was, and you can just fix your answer. Now you might be asking, why are we doing this? This is algebra, but we are going to see solving equations in geometry. A lot of geometry, you may have heard me say it already, comes down to algebra. So we will be doing this. You're going to be solving equations for the rest of your lives. It's going to be great. I promise. So it does work. The left-hand side did equal the right-hand side, so we're good to go. All right, so again, some of us did not get to finish the laws of logic. So if you did, this will be a nice review. And if you did not, then you're going to want to grab those notes from last class to fill these in. So the first law we have is the law of detachment. And we have a conditional statement here, the if then, and I'm going to write it virtually, or not virtually, vertically. So if P implies Q, so we talked about how this little arrow means implies. That's the English word we represent with that arrow, is true, and P is true, then Q is true. And a lot of times you'll see 3 little dots written here, and this means therefore. Mathematicians decided that was going to be a great shorthand way to write therefore. You'll see these 3 dots a lot of the times at the end of a proof. It's sort of like a matter of fact. Therefore, this is true. So it kind of makes sense, right? If P implies Q is true and P is true, then that must mean that Q is true. That if-then statement, that conclusion, that's the conclusion part. Let's see an example. So if I study for the test, that's P, then I will pass, that's Q. Okay, so here's a fact. I studied for the test. So what's going to happen? What do we know is true? Based on the statements, therefore, I will pass. So one thing I forgot to mention is that we are using the letters P and Q and sometimes R, sometimes S. And you'll see these letters a lot in our logic unit, mostly because we use other letters for other things. You might remember that M stands for slope. A lot of times when we're solving an equation, it's X, Y, and Z. And mathematicians just decided we're gonna keep things, in their own lane. So they decided this lane was going to be P, Q's, and R's. It could really be any letter. It's just a letter representing this part of the statement. All right, let's try this one. Remember, you can pause this. If angle A is 45 degrees, that's P, then A is acute. That's true. So is P implies Q true? Yes, it is, right? Because we know a 45-degree angle is an acute angle. So that's true. So then it gives us P again, right? These match up. measure of angle A is 45 degrees. So that's a statement. We took a, oh boy, here we go. Is it a protractor or a compass? I wish you guys were here. I told you I'd do this. We took a measuring device and we found that angle A is 45 degrees. So we decided it's true. We determined. Therefore, angle A is acute. Angle A is acute. This one seems a little like, duh, but the steps we're using and the logic we're using are going to help us when we get to do our proofs. So is this an example of detachment? So whenever I'm given an example like this with just words, I don't see any P's and Q's, I go ahead and I try to label it. That helps me remember my rule. So here's the rule of detachment, right? Just like that. So if I can get these parts to match up and they make sense, then we have a detachment. So if I brush my teeth, I'll label that P, then I will not get cavities. My teeth are clean. These are not the exact same statements. This is not P. This is something else. We'll call it R. It has to be the exact same statement. My teeth are clean. Maybe they're clean because you went to the dentist. Maybe they're clean because you used mouthwash. They're not the same. So then here's Q. So we have P, Q, R, and Q. Oh, nope. This is not an example of detachment, even though it very closely looks like one. So you need to be careful when you're looking at the meaning of the sentences. All right, let's talk about the law of syllogism. So again, I'm going to write this out vertically for us. Here's the first statement. P implies Q, Q implies R, then P implies R is true. This is like the transitive property. I remember a student reminded me of that. If A equals B and B equals C, then A equals C. It has to be true. It's transitive because these are the same. The middle ones are the same, then of course A and C are the same. That should go to C. Let me fix that. There we go. This is the same thing. So we have P implies Q. Look, these are the ones that match up. And Q implies R, then of course P is going to imply R. So let's look at an example. Again, I like to label it, so we're going to do this first part P. I have the colors here. And Q. I can get a car. I can get a car. That's Q. Now this word can, that's more of like an English, arbitrary English word. It doesn't change the meaning of that sentence. Some people say, oh, it's not the same exact sentence. But it is. The other one was totally different. A different action. All right, I get a job is a new sentence, so we're going to label that R. So right away, we have statements of syllogism, but you also have to think, oh, well, is it true? Does it make sense? If I pass the driving test, then I can get a car. So their parents must have said that. If I get a car, then I can get a job. Therefore, if I pass the driving test, I can get a job. It's so nice when logic makes sense. I guess that's the definition of logic, right? So here's our conditional from that. If I pass the driving test, then I can get a car. If, then. All right, so again, let's try. We're going to label. Two angles are vertical, P, then the angles are congruent. If the angles are congruent, Q, then they're equal. So definitely have it set up. So let's see, that means, therefore, P implies R. If two angles are vertical, and you know what? We haven't even talked about this yet. We're going to talk about this next week. This is a good example then. Oops, I didn't not mean to write that arrow. I meant to write the actual English word. Then their measures are equal. This is true. So when you have these parts match up exactly, then you know that the law follows. Is this an example? If I practice soccer, P, then I'll score in the game, Q. If I practice soccer, there's another P, then we will win. Oh, that's a whole other part of a sentence, so I'll make it R. Therefore, if I practice soccer, we will win. So this can be tricky. Let's write out what we have. P implies Q, P implies R, therefore P implies R. No, this is not syllogism. Remember, you have to have that transitive property. This needs to be a Q here in order for that to work. So no, this is not. Even though it looks like it might be. So I guarantee you guys have used logic, and you do use logic almost every single day of your lives. If you're on social media or you watch TV, you've seen commercials or advertisements, and advertising uses logic all the time. Look at this one. Supreme Clean Whitening Toothpaste. 9 out of 10 dentists can't be wrong. What about that 10th dentist? If you are a dentist, you can't be wrong. We can make up so many conditional statements about this. If you use Supreme Whitening Toothpaste, you can't be wrong. Oh, what about this one? If I drink Coca-Cola, I will be happy. If I drink Coca-Cola, all the girls will like me. I don't know. We could say some other things. If I drink Coca-Cola, my teeth will rot. But just based on the image, we're already sort of forming logical ideas about the advertising. And they do that on purpose. It's psychological. So be careful. All right, so let's get more into these conditional statements. There are 3 types of conditional statements we're going to work with. The first one is converse, second one is inverse, and then the third one is called the contrapositive. So let's see what these are. The converse. All right, so here's our original. P implies Q. That's what we stick with. That's sort of our original. Always. The converse is the reverse. Converse is the reverse, and that's when you just flip it. You reverse it. The Q will come first. And we're going to see this written out using actual words, but this is the symbolic notation. So for the converse, you just reverse the statement. So let's try it. It says find the converse. Here's the original conditional. If you like tennis, then you play on the tennis team. So sometimes I like to label, this is P, this is Q. So remember, the converse is you reverse it. So QP. So all we do is flip the parts. So instead of if you like tennis, we're going to have if you play on the tennis team. If you play on the tennis team, then we're going to reverse it. So we'll put the first part second. Then you like tennis. All right, let's try it with the second one. If x is odd, that's going to be our P. Then 2x is even. That'll be our Q. The converse says to reverse it. So if 2x is even, then x is odd. And remember from science, this is reversing our hypothesis and our conclusion. So sometimes it might still be true, and sometimes it might make it false. We're going to look at that. All right, C. If you are happy as P, then you are in math class. Yay! I'm happy. If you are in math class, we're reversing it, then you are happy. So some people might argue the first statement, it could be true. Maybe you're happy because you had a really great breakfast. Maybe you're happy because it's your birthday. I mean, you're still in math class, but maybe you're happy for other reasons. This second sentence,
I have two U's here. The second sentence is insinuating you're happy because you're in math class, right? That's the conclusion of this hypothesis. So that's how it can kind of be true or false depending on, well, depending on who you are sometimes and also depending on the order in which it's written. All right, let's talk about the inverse. So remember the original is P implies Q. We always go back to that. So the inverse is essentially like the negative. Whoops. So I remember this one because we use the term inverse a lot when we're solving those equations. Remember we used it in our warm-up? The inverse of addition is subtraction. So it's the opposite. So you sort of make it negative. That's the word we use in geometry is we negate it. So you make it the opposite. So I actually don't love the term negative here. We're going to stick with negate or opposite. So here's how we write it. You use this little curvy tilde. That lives on your keyboard near the escape button next to the 1 key if you're looking for it, and you put it in front of the letter. And the way we read this is we say not. Not P implies not Q. So you make whatever the statement is, you make it the opposite in meaning. So let's try. So inverse again is not P, not Q. I'm going to write it up here. Not P implies not Q. So you keep the order the same, you just make the meaning opposite. So I still like to label. I'm just a labeler. So to make this an inverse, we're going to not it. Not it. So we would say if it is not 6 p.m., and it's really best to just put a not in front because you don't want to change the entire sentence to not know where you came from. You don't want to say if it's 10 p.m. Yes, 10 p.m. is different from 6 p.m., but you're trying to make it sort of the exact opposite. That's why we just put not in front. Then it is not time for dinner. There we go. Here's letter B. If you're in geometry, then you rock. If you are not in geometry, then you do not rock or you don't rock. I'm sure you would still rock for other reasons. All right, C. If you are not sleeping, then you are awake. Whoops, forgot my A. So you're just putting not in front of them or don't. I mean, I guess in this one you could put if you are awake. If you're, yeah, that would be okay because you know that's the exact opposite. All right, let's talk about the contrapositive. The contrapositive is both. So here's the original. P implies Q. The contrapositive says we do both to it. We reverse it and we negate it. Reverse and negate. So it's both of them in one. So it's going to be not Q implies not P. So see, we flipped the parts and we made them negative. Or we negated them. Let's try it. I'm going to label. Now I think you don't have to do it this way, but I think sometimes it's easier to go from the conditional to the converse, to the contrapositive. Some people can go straight to the contrapositive. It's totally up to you. Remember, we're flipping the parts and we're making them opposite. So let's try A here. First, the converse is the reverse. So if you were in Connecticut, so I just wrote the Q first, then you visited Hartford. Okay, now that we flipped it, we can make it negative.
So if you were not in Connecticut, then you did not, or didn't, did not. I don't know when is it best to use that form. I'm not an English major. Maybe you guys can tell me next class. When do you know to use didn't or did not? Then you didn't visit Hartford. So we flipped the parts, we put Q first, and we negated them. We made them not, or opposite. Let's try B. Let's go straight to the contrapositive. I think you guys can do it. I'm going to flip it and make it negative. So if you did not pass the class, then you did not do your homework. And we're not so much worried about grammar and English here. Not really. We just want to make sure that you're getting the idea of the converse and the inverse and the contrapositive, the logic behind it. So let's try the last one. This is P and this is Q. I'm going to go straight to the contrapositive. If you know. If it is not winter, remember we're going to try to make it opposite as much as possible. Like you wouldn't want to say if it is summer, because it could be autumn or spring. So we just want to say if it is not winter, then you are not cold. Now we can talk all day long whether we think this is true or false, and we will get to that. But for now, we're just talking about the different types of conditional statements. So we did talk about negation already when we looked at the inverse. So all I wanted to do here is like formally tell you the symbol for negation is the tilde, and it means the opposite. To do the opposite. You might also see it written like this. So like that. Or like that. And I don't know where that symbol is on the keyboard. It's kind of like a rotated L, capital L. But you might see it written like this in your OMHS or on the SOL. So I'm glad I remembered to tell you that. I tend to write the tilde because it's pretty. All right, so write the negation of the following. So remember, this is another sort of task in not changing the actual words, but just making it negative or opposite. So the cat is not sleepy. All right, B, your friend is not short. So we wouldn't say your friend is tall because that's changing the words, right? We just want to try to negate it. So not short would be your friend is short. So see, you're not always making it not. That sounds funny. I'm glad we have this example here. The point is you're making it opposite. So sometimes you're going to take the not away if that's what you're given. My mom is mean. No, my mom is not mean. And this is true. My mom is not mean. She's one of the nicest people on the earth. All right, so we have this chart here. This is a great chart to keep handy. You might even want to print this out and keep it in your workspace just until you kind of get used to it. You can even like tape it on your bathroom mirror, on your refrigerator, anywhere. So we're going to talk about the conditional as a sentence and then as the symbols. So in conditional, we write it as P implies Q. So remember, the converse is the reverse. So if Q, then P. And I'll put reverse here in parentheses. So, oops. So Q comes first, implies P. All right, the inverse So remember, the inverse is negating this. So if the original, we always go back to the conditional. So if not P, then not Q. Gate. Maybe I'll do that. Reverse. Let me delete this. There we go. So you can write it using the curly. If P implies not Q, not P implies not Q, or this little sort of bracket thing. Okay, contrapositive is both. So we're going to flip it and we're going to negate it. So if not Q, then not P. All right. Lastly, this is called the biconditional. We're going to learn about the biconditional in class on Thursday. So just going to give it to you here so you can put it in your chart, but we're going to talk more about it on Thursday. So the way we write this is, oops, P, and it's a double arrow. And the way we say this is P implies Q if and only if. If and only if. So sometimes, I just wrote 3 F's. Sometimes you'll see a shorthand of IFF, if and only if. I just did it again. If and only if, IFF is the shorthand for that. It's the double arrow, if and only if. So it means it goes both ways in both directions. It's true in both directions. So we're going to learn more about this on Thursday, the biconditional. All right, so I pulled this example straight from the latest released SOL, and it wants us to click and drag the answers to the correct boxes. So if you were taking the test, you would be able to click on these and drag them into those spaces. I don't have that interactive feature here, so we're just going to write it. It tells you, let B represent Brent works this summer. I'm sorry, P. Let Q represent Brent takes a vacation. Symbolically represent the following argument. So this is when I say, and I've said it all class, label, label, label. So I would even maybe, if you were taking this on a test, you could use, on the SOL, they have a digital pen just like I'm using, and you can label the screen if you're showing some work on the screen. Or you could just write it on your paper. Remember that the only thing that counts for the answers is what goes in this box. So you can write all over the page if you want. Just make sure you drag and drop the answers into the boxes. So I'm going to label this P because it told me it was P. It could be anything. It could be T, Q, but they told me it's P. Brent works in the summer. Then he will not take a vacation. Be careful here. Look at this, not. But Q is he takes a vacation. So how would we write he will not take a vacation? That's not Q. All right, the second sentence here says Brent takes a vacation. Oh, they said let that be Q. Therefore, we talked about therefore means those 3 dots. Therefore, Brent does not work this summer. So P was work this summer, so this is going to be not P. So I've basically got the answers there. I just need to find the ones down here and match them up. So the first sentence is P. Remember the word then translates to that arrow. P implies not Q. Here it is. I would click it and drag it up here. And then Q. Here's Q. Therefore, not P. Here it is. So be really careful because if you look down here in the answer box, look, they have just regular not P. That's tricky. But they told us therefore, so we know therefore means those 3 little dots. So you want to make sure to pick that one. All right, you guys, success. That was a lot of fun. We'll see you guys on Thursday to continue this and work towards our 2-column proofs. Have a great day. Bye, everybody.